Hi there, myself Madhav Jha. I welcome you to Code Chef and let's have a look at this question.
The problem is unreachable. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. There are n people standing in a line. The ith person from the left has a strength of AI and it is guaranteed that the value of AI will either be 1 or 2 for each person. Now suppose the person I is holding a ball. They can throw the ball to person J if and only if AI divides the value of absolute difference between I and J. Now, if the strength of the person I divides the distance between I and J, then they can successfully throw the ball. Our task is to find whether there exists a pair of people I and J such that if the person I is initially holding a ball, there is no sequence of 0 or more throws that will allow the person J to receive the ball. So in this case, we have the person standing at I and we want to throw the ball at person J. And we can only throw this if the absolute difference between I and J, or you can call it the distance, is divisible by the value of AI. And remember that AI is either 1 or 2. So we have to find a pair I and J in such a way that in any sequence of move, I cannot throw the ball to J. Even if there are in between other players or other persons, the ball cannot reach successfully to J. If there exists such a pair, our answer would be yes, otherwise our answer would be no. Let's see the input format. So we have t test cases and for each test case we have two lines. The first line contains the single integer n, that is the number of people in the line or number of elements in our array A. And the second line will have n spaced integers. These are a1, a2 till an, that is the strength of the people. As for the output, if there exists a valid pair of I and j such that I cannot throw the ball to j, then we will print the answer yes, otherwise we will print no. As for the constraints, number of test cases will go from 1 to 10 raised to 5. Length of our array A will go from 2 to 10 into 2 into 10 raised to 5. And the value of elements will always be just 1 and 2. Let's see some sample inputs. So for the first sample input, value of n is 3, and in our array A, the three elements are 1, 2, and 2. Now, a valid pair of I and j can easily be 2 and 1. So if I choose 2 and 1, so in this case 2 is my I and 1 is my j. So if I'm standing at I and I want to throw the ball at j, that is 1. So since I am at I can only throw where the distances are divisible by 2. That is, I can throw to the distance 2, 4, 6, 8. That is multiples of 2. But if you see, the distance between I and j in this case is not divisible by 2 because I and j is just 1. So the distance 1 is not divisible by 2. Therefore, this is a valid pair and our answer is yes, that there exists a valid pair where I will not be able to throw the ball to j. Let's see how we can approach the solution. So let's check when our I and the element at the ith position is 1. If this is the case, then we can throw the ball to any j. Why? Because any distance that we have, it will always be divisible by 1, right? So the only concern is when the element at ith position is 2. Because if it's 2, it can only go to the multiples of 2, either in the left direction or in the right direction. So let's understand what if our I is at a even position. So if our I is at an even position, let's say at 2, we can throw the ball to 4, we can throw it to 6, we can throw it to 8, or we can throw it to 10 and so on. But what if we choose a pair, something like this? If you want to throw the ball between 3 and 6, will it be possible? No, because even for 6, it can throw the ball to the multiples of 2, never to the odd position. This is when our I is at an even position, right? What if it's at odd? In this case, we'll just replace this, right? So in this case now, rather than being at 2, 3, Again, 2 are at these positions, right? In between them. Again, we can throw them to the other twos, right? Or the other positions, the other odd positions. But if we want to throw it to any middle even position, we cannot do that. So it's very easy. What we're going to do is we will check for all odd positions. If at all odd positions only 2 is present, it means that from the odd position we can never go to even position. And vice versa, if at all odd positions we only have 2, we can never reach the even position. But what would happen if there's a 1 in between? So if there's a 1 in between, so from any 2 we can send the ball to 1 first, and as we have seen, 1 can send the ball to anyone. So to check, we'll simply check all the even positions and check if there exist all 2's there, then our answer would be yes. And if that happens for odd, in any of those 2 cases, our answer would be yes. But if at both of them, at any position 1 exists, our answer would be no, because then we will be able to throw the ball from I to any position j. And with this, we'll get our solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve, and solve we take the input of n, and then we take the input of our array. Then we check first for all odd positions and then for all even positions. While we are taking the input, if any of this is 1, that would mean that if we are going over all the odd positions, first we can throw the ball to 1 and then 1 can give the ball to anyone else. So we'll set the flag of odd to 1. It means that all the positions or persons standing at odd positions are good to go and they can send the ball to any other j. Similarly, we'll check for even. But if at all odd positions only 2 exist or at all even positions only 2 exist, it would mean that the even ones cannot send the ball to odd ones and odd cannot send the ball to even. If any one of this is true, our answer would be yes. But if both of them have 1 at a even and at a odd position, our answer would be no. Because in that case, ball can be thrown from one I to any other j. And as you can see, I have got an AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve. In solve, we take the input of n and then our array. Then we check for all even position and find if there exists any 1 in even positions. And we do the same for odd. If at both even and odd positions there exist 1, it would mean that ball can be sent from I to j. But if that's not the case, it would mean that there exists a pair where ball cannot be sent. That would be either from even to odd position or from odd to an even position. And with that we print our answer. And as you can see, I've got an AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.